And good morning. Oh man, voice still waking up. Sun's coming over the hills. I always find it tough for a time change. Gotta get in sync with everything again. I like the song. A little big band thing going on. I'm trying to find the terminal again. There it is. All right. I think part of the issue I'm having with this is the zero packet. And it's part of the reason why we can't reproduce this with tests. Because in, what was it? We called it producer over here, stream producer. No, not this one. Oh, no, it is. These elements here. I think there's something fundamentally different in that the other side of this, it is very, very happy to, the game server actually is, it actually does a little bit more in that it actually consumes a packet in here. I think that's confusing the rest of it. Let's see. Oh, wow. Okay. Well, is there a way for us to prove that this is the issue? I could just not send those packets. That's one way. Just not send them. We're gonna break things though. But it would show us that we might see enough before it breaks. At least let us know if that's kind of the cause. So here, if we go to Godot, let's go full screen up here. So in this case, write message, yada yada yada. It's doing its thing, fine. Where's our type 0 happening? Gonna be a write. Gonna be in protocol. Send ID packet, there it is. Can we just comment that out? Also pass in there. Anybody else do that? Let's see. Not in this file. Let's check all files. Sure. Not whole words, just match the case. Oh, just one place. Okay, so that should be it for that. To the game server. Oh, you know what I forgot to do? Got to be able to see chat. You can't see chat yet. There we go. Hey, MaxDev, thank you for the follow. It's 10 hours ago. Okay. Oh, is the server still running from last time? Okay, let's get a fresh run on it. There we go. We still have the MIO stuff and the Tokyo elements polling or logging. All right. Fire up the game client. The login for character 1, which is Fuzzy Lips there. Hiding remaining 170. Okay. Now, what did we get so far? Oh, look at that. We got packet 3, packet 31. Scroll down some. We also got 3 and 30, so that is causing it. Oh, goodness. And if I click in the puddle, I'm expecting it to not do anything because we need a subject. But yeah, there's packet 2 right away. Before that would take 3 clicks. Okay, so what this means, not happy about this. This means that in our handling of the packet 0 in here, we actually consume it. Where's it? Here it is. So are we in the decoder? Oh, we have outline, don't we? Decoder state. Simple decoder. There we go. Here's our. That means that sometimes when we consume packet 0 and don't return anything, it messes stuff up. Oh yeah, you can actually see that this is an issue over here. Stream subject is required. So how can we actually mimic that in a test on the other side? We create one of these, just copy this across. We just do something with like U8s or something. If it has like a packet 0, do the same sort of thing. A little contrived test would probably help out. I wonder what the problem is. Let's look at this for a minute. We come in here. So when it signals, what's going to happen? Let's start at the top. We have a new packet codec, and this is actually inside of a frame reader and a framed writer. So the TCP socket will signal, say, hey, you have data. The framed reader, say, we've got some bytes for you. Start parsing this. We'll look at the length here. We'll say, hey, we have enough or not, right? Once we have enough, we look at the length here. We get to n, and we reserve a number of bytes. Say, okay, cool. Oh, who calls decode head? Let's look at that. That's down here in decode. So once we have n number of bytes, we decode the data. And once once we start decoding data. Let's add a bit more logging to this. I want to see what's going on, better detail. All right, so from the top, it's known. I'm not going to add logging to that. We know what the initial state is. We have a trace. Code head, and that should decode self. Bytes mutable. I'm going to go ahead and add source to that. I want to see what the packets are. It's called. This is going to be really, really verbose. So we have so many coming out. Saving n, fine. Putting data, let's do the same thing. Actually, did we get n in here? No, this one we actually return n. We determine what n is. Down here, self-source are ignored. So we'll have n there, but we won't have source. Question mark src, plus that on there. Splitting to n plus 2. All right. A little bit further down, we have decode, giving self and source. That's fine. We'll see a lot of that coming in through here, because we'll call decode head there, and down here we will call decode data. You know what? That's going to be right inside that function call. We don't need that. All right, and here we inspect and see what the type of data 0 is. So this should be our packet type here. Question mark data 0. Our packet type. In this case, we advance past the packet type. Oh, does it not know this? Okay, let's... Can I just use an expression here? We can copy that out. There we go. let's there we go. Now we can see more code. Okay, any other logging here? Guess we would replace ID. Let's log that. Replacing subject ID. Advancing 17. Then we call decode on it. Fine. I mean, for all we know, this portion here is wrong. We do not need to log the stats at the moment. Okay, I think that's it. We're not going to be looking at the encoder stuff. This is going to be chatty. So we're going to be looking for packet 0 coming in, being identified, and things going poorly from there. Want to cargo build dev run. Okay, little OCD. Man, we haven't looked at the stat server in forever. I want to get a look at that again someday. Funny because it starts up, it runs, it's doing stuff right now. And we're ignoring it. All right, let's restart the game client. Oh, I also have to enable. Where to go? It's in protocol. There we go. Start the game. Logging in. A lot of stuff going on. I'm going to select Captain Fuzzy Lips. Okay. Add some space around that. This is where things start to go wrong, right? We get the different packets, and right now we should have received a number of different packets, including packet 30 and 31. I think inside of here we'll only see 31 if this is reproducing the way we've seen it in the past. So I just see 29 in there. Alright. Going to take the game off there. Alright, so what's happening? We get the Tokyo saying we need to do a frame read decode. And this is because there was some sort of event on the stream. State is in head. We're going to start decoding this packet. What is this packet? This is a packet that has OX14. That's what, 20 bytes? That's a 16 plus 4, 20. What do we have here? So this, the first two, that's going to be the length. The next one here, that's going to be the type. What is 1D here? 1D is 29, so that's packet 29. 82 is like a 2-length array. Okay. Is the length correct? So when we have this, we actually consume 20 bytes. And it's 20. Decoding data, and it's 20. I wonder what's... Hold on the game client, what is packet 29? Yes, we are fixing the same bug. This is exactly the same bug from last week. I'm feeling like this is kind of like a best 2 out of 3. We're in round 2. Morning, 715209. Because I think what's really happening is that, yeah, that it's exactly the same bug, and that our packet 0, which is getting consumed by the packet decoder, is actually causing issues. Oh, I was going to look at what message packet 29 is. Load actor. Let's see. Why didn't we see packet 30 in there? Well, it's probably because of the bug. Alright, so, beginning of this, 20 bytes. I guess is 20 bytes expected for called a load actor? You're still working on your IRC parser? Yeah. So let's see. For packet 29, look, let's just validate that what we're expecting is actual here. Load actor. Oops. Load actor. I see, and that's an ID callback, so it has an ID in it, which should take 17 bytes. A callback, which is like 2 bytes or so. So 20 seems about right for that. Yeah, type callback. This is going to be the array, the marker for the type value. Yeah. Okay, so that should be okay. Either okay or it's off by 1. You always say it's capacity of 19. When we deserialize this, let's... Okay, hold on. ID callback. See, here we're saying the length is 19 when we serialize it. So why is it saying it's 20? Let's run this test. Ergo test. This is the layout. We have a list. ID 2 because it's a callback. It's a value, that's the ID of the callback. Alright, so we have 16 here, 17, 18, 19. And that test passes. Did it actually run the test? Oh, there it is. So why did it say it was 20? Okay. There's the shutdown. We're going back up to the code here. What is it? Why is it saying it's 20? It should be 21 or 19. So we have length. All right, so it's 19 plus 2 should be 21 that we're reserving. Where is this? TCP server codec. Why are we not reserving 21? Reserve N. Ensure that the buffer has enough space to read the incoming payload. When we call reserve, is that additional capacity? Reserve asks you for at least additional more bytes to be inserted. Even okay. So N here should just be that, and that here we say we need 2 bytes. We reserve a number more. How many more did we reserve? Reserving N equals 20 here. So why 20? I guess we could look at the bytes, see what's coming in. What do we have up above this? So that wrote a bunch of stuff out. I'm wondering if it's consistently off like that. Let's check our first packet. State head, decoding, here's our username and password, reserving 26. Now what do we need 26 for? So should have been waiting 2. I wonder if what we should do first also say that this byte's mutable. Oh, we don't have it up here, so we can't say, oh, I want to reserve 2 right away. And when we first come in, decode head. See, the calls to reserve are really optimizations. Because it's not going to basically come back until it's filled that. That should be okay now. All right. So in this case, we do go to head. We have something that's, was it 16? 26 characters? I think that's 26. Got 1, 2, 3, 4, 5, 6, 7, 8 up to the U. 9 is the @ sign. 14 to the period. 18 to the H. 19, 20, 21, 22, 23, 24, 25, 26. That is 26. That checks out. It says it's decoding it. Splitting and reserving up to that. Oh, I wonder if our reserving extra is actually putting that off. It's making the buffer larger. We have to fill that before it comes back to us. Oh. Okay, so where are we calling reserve on these? Look. Yes. This one, I think that's fine. We're reserving n number of additional bytes. If we look at the head packet, hey, we need this many more. Okay. Decode data. We'll receive something. We're not reserving it here. We're just splitting to that mark. Down here, after we call decode data, we're making sure that the next call around has enough space to fill. Now for us, see this reserve here seems to make sense to me. Saying like, hey, you just finished filling that section of buffer. How much more do you need? The problem I see here is that it's going to reserve additional capacity. But that is common to these code branches. In one case, the error is likely to do with this code here. Because in the client, when we stop sending packet 0, everything's fine. All right, let's take a closer look there. So this reserve is probably fine. Move past the packet length. We inspect the type, which is the first byte there. We need that packet type for other branch. Okay, that gets parsed. We'll leave that. Now in this case, we're moving past data type there. We do a CBOR from slice of that element. Does that do? Codes value from CBOR data in a slice. Does that advance pointer? We have to do that. Looks like we have to. And then we call decode data again. Yeah, we kind of recurse here. So at this point, we're basically saying that this thing's been consumed. That should be it. But why only 17 here? Why not further? Here's the length. So this 19. We saw earlier that it was basically 20. Because 20 had the ID in it. Let's go back up and look. Here's 20. That should be basically the 19 with one additional value. This has two values. This has the type and the callback ID. All right. But that can't be the issue because when I took packet 0 out, it parsed that just fine. So let's see, we get past packet 29. Going to convert packet. Serving 2, moving past packet length. 9, we're doing a try from. This is in the else case, the common case. I'm going to convert into packet such and such. What do we have here? This is the callback ID or the packet type. This is 29 X. That's 29. This is our callback ID, and then we have the element, the thing that we actually want to choose. Fine, looks good. Converting kind. Okay, what's this say? Frame decoded from buffer. So we got packet. Coming data, sending data, channel 1. Attempting to decode a frame. What is this? Decode head source. What? Why is it empty? There's no bytes there unless it's something that can't be displayed, but then like zeros are still displayed when you see these up here. Why is that empty? Have none. Why did that signal? Oh, does it just keep reading until it has nothing? That could be. Waker registration. Okay. This is the other thread. I think has been given the information. It's processing the entry. Oh, it's got it parsed. It moves it between streams at this point. Stream connected to the other side. Okay, now we get another packet, state head. This is a lot of data. Why do we say that we're reserving 18 for this? I mean, it looks like we have well more than 18. What does this say? This says reserving 18. Get this, why is this like this? Decoding, so what do we have here? That's 16, 17, 18. This is saying that the packet length is 18 here. Sure, that's why we're reserving that. And we have the length, then we have the type. So there's packet 0. If we go to the next one here, looks like this is where the next one starts. This looks like some sort of packet 3. Yeah, there's packet 3. Right there. Oh, there. I have packet. Maybe I'm not parsing that right. Okay, so here, 17, 18. Why is that only 18 for packet 0? Packet 0 needs to be 16 for the data, 1 for the tag, I believe, and then 1 for the kind. That's 18. Okay. Look at this. There's 0. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18. Yeah, that's good. And then we get the next packet. The question is, should we be calling reserve when we have much more than 18 bytes? Look at the docs on reserve. Tokyo. Tokyo util, I think. No, this is in bytes. There it is. Reserves capacity for at least additional more bytes to be inserted into the given bytes mute. More than additional bytes may be reserved in order to avoid frequent allocations. Call to reserve may result in an allocation. Before allocating new buffer space, the function will attempt to reclaim space in the existing buffer. The current handle references a small view in the original buffer, and all other handles have been dropped, then the requested capacity is less than or equal to the existing capacity. And the current view will be copied to the front of the buffer, and the handle will take ownership of the full buffer. Okay. And what happens let's see, it panics if capacity overflows use size. Oh goodness. Can you imagine handling that much data? That'd be crazy. But I'm kind of curious about though. Oh, maybe this answers the question. So if it currently has, say, oh, what is this? 1, 2, hello is what, 5 characters? So we have 5 characters, right? And we reserve 64, then our capacity now 69. So it's not going to come back to us until, well, that's there. So we shouldn't be calling reserve if we already have that data available. Let's also look at the framed read. I think it talks about this as well. Codec and framed. There's a description. Oh, interesting. What do they talk about that? Codec. Decoder. Buffer management. Before returning from the function, implementations should ensure that the buffer has appropriate capacity in anticipation of future calls to decode. For example, if frames have a fixed length, or if the length of the current frame is known from a header, possible buffer management strategy is this. It minimizes reallocations and over allocations. All right, but if we make it inefficient, for the sake of testing this, that might be a strategy. And one option, remove a couple of those reserves, see if that makes a difference. Here, we should have gone through, processed packet 0, then we'll process packet 3. We're not seeing that. So when we come through, reserve for 18, it's going to be packet 0. Okay, we start to decode this. Splitting to n plus 2. Is this correct? I think that was correct in that there's the end of packet 0. Looks like we have a CC 9815. Good. Splitting state to head, reserving 2, moving past packet length. So we should be talking about this here. Oh, no, that's still for packet 0, for data type 0. Is that correct? It's the type and... so yes, we start at the P there, then we have 8A, etc. That looks good. So we end in CC 9815, looks good. Replacing subject ID, advancing 17. Oh, well, decode head B is 0. What happened to the rest of our data? But we had like a ton of data in here. Where's the rest of it? It should have been like from here. Where's all that data? There's our bug. Oh wow, I left you in the browser. All right, to go over this again. What's happening here? So we have a couple packets. The first packet is here. Okay. This is what I call packet 0. It has a length of 18 and oh, that's fine. That's okay. I just feel guilty sometimes. When I look up, I'm like, oh, they've been in there. Some people are just quiet and they don't want to interrupt. But don't be afraid to interrupt. Don't be afraid. So yes, our first packet is here. After that 15, I guess that's really in, what is it? 21 at the end there. OX21. OX, I guess it's OX15 in hex. The value of that number is 21. Whatever. I mean, isn't that difficult to talk about like values in different bases? Do you call that 15 here? Well, it's not actually the value 15. It looks like a 15. It's really the value 21. Yeah. Anyhow. So what ends up happening down here is that we split that first packet off, and then we go to decode again, the next head, and our data's gone. Like the rest of the buffer has vanished. The rest of this, it's gone. Yeah, it's X15. That's right. Oh, X15. It's funny. It's just so hard sometimes to disassociate the value of a number from how it looks, how it's represented. So this data here that we passed through, oh, where'd that go wrong? Is it from the slice here? I mean, maybe I should have given that something else. Wow. From data. Data. Okay, I'm gonna say A1, 2, 3. 2, 3, 4, 5. I want to see which one of these is actually trimming that. I'm guessing it's actually this CBOR from Slice. I don't know why it would do that. This one doesn't really make sense. Whatever. That's how I feel. Ah. All right, let's try that again. That makes sense why things stop working. Kind of. It kind of makes sense. So where are those packets coming from later? Because I thought things were buffered up. Is it still in that buffer? Did I somehow shadow data? It doesn't look like it. Oh, that's okay. That's up. That's running. Let's reconnect the game client. Log in. Restart it. We can choose Captain Fuzzy Lips there. Could have given us some data. And yes, look, this one. Or wow, okay. Same thing as before. We had a lot of data here. Coming up to that first packet, or to coming up to the second packet at index 1 there. Go from slice, and this is all short now. Which data is that showing? 8A. The next one is also 8A, but it's packet 3, so it's OX1203. Interesting. Okay. So I find that it's interesting here that 5, the one, this advance, well, technically that's not all that interesting, but what's really interesting is that the whole thing here, let's say from slice, this isn't very long. This is just the length of packet 0. So what we're getting back from, here isn't the whole story. Let's decode data. It's not giving back everything. Is it this split? Splitting to n plus 2? Oh, I see. So this is actually returning a section of the buffer, which means that we cannot recurse. Oh. All right. So we need some other way to signal that. Here we are relying on match to kind of return the right thing. We could loop, just keep doing this until something returns. It's not a bad option. What would that look like? We would decode the data and it would handle that data. It would not return here. Let's get rid of our ahs. Okay. We wouldn't recurse there. And advancing seems pointless because we're just given a view into this packet. Because here we're splitting it. Source split, blah, blah, blah. Does split advance it too? Splits the buffer into 2, okay, yada yada. Afterwards, oh, come on. Self contains elements at to length. And the returning bytes mute contains elements 0 to that. I see, so it's like a split in like JavaScript on a string or whatever. So technically there's no point down below in doing an advance or dealing with any of that stuff. So on source, we can do a reserve. Data, this is kind of temporal. It's okay, that's fine. We're parsing that. But calling a reserve or anything else inside of here is not going to make sense. And we don't. Perfect. Only thing that's suspect is this decode. We should get rid of. Yes, I know that your return type is different than the rest because I technically don't want to return from you like that anymore. I'll put a semicolon there. In these cases, we will explicitly return because we're going to loop otherwise. Loop. Add that in. Go to the end, toss another curly bracket on there. There we want to return. Here we want to return. I thought there was one more. Yes, this error case we want to return. Oh, interesting. Why is that a return from that? Wouldn't that have been some other loop? No, that's okay. So we enter a loop, decode some data, Is that the question here? Is this far enough? Should it actually be up here? I think it needs to go further. In which case, we have to return from these as well. We do return already here. Otherwise, n is set. Okay. Pass packet length. All right, let's try that out. Start the game. How was everyone's weekend? I had fun binge watching kid anime stuff. Can't even remember what you did. That must have been awesome. Just gonna pour some tea. There we go. Oh, you ordered microcontrollers and tinkered. Oh, very cool. Now let's connect. Log in. So far, so good. Select one. That was a lot more data coming in here. That might have been it. I don't want to read through that. I just want to click. Will you go to your puddle, Connor? Went to his puddle. Right away. Oh, we found the issue. That's refreshing that it wasn't in Stream Multiplexer. Oh, look, the game is working. Oh, happy day. Yeah, we found it. So here, we can click around. We can go look at the shore. Oh, that opens up. Oh, we can sit on the little peninsula here for a moment. Contemplate what to do next. Connor, step away from the shore. All right. That is great. Oh, I'm so glad that was round 2. We won. All right. The best 2 of 3. We're just calling it. I'm sure the bug will have its day in the future, but we win this one. That is awesome. That was such a bug. Wow. Such a good bug. there. And I'm glad that we actually solved this other thing. I was gonna have to come back and do that anyways. Just didn't realize that it wasn't like going into this. So what did we do over here? Added disconnecting. Yes, we did that. We have the status. This is stream multiplexer. What's different here? Oh, packet. Stream ID, yes, that we wanted to change. Oh dear. Torres. Well, thank you. Good clip. Thank you. In this case, oh my goodness, yes, and this has the features and ordered stuff. Ooh, yeah. Gotta release this too. Oh, just in time for you to hit some lunch. Yeah, that's right. Yeah, you're running a little late today. I guess I was running late too. I am looking forward to the next stages of this project. Now we're gonna get the probably linked out working next, and then zoning. Goodness, all kind of coming back together. All right. These are some good changes. Okay. So how do we summarize this? What this here for stream multiplexer, which I think we need for this. Okay, two things here. One of them was the streams, or we switched to features unordered instead of a select all. And the point of that was so that we could have join and leave messages for channels. This is an extra packet. Yeah, this needs to be cleaned up. Hello, Carter. Thank you for hanging out. Have a good lunch, man. Now let's review some of these changes for Stream Multiplexer before we get another version of that out. I think, let's see, where is it? All right, take care. Oh, you're welcome. Yeah. And by all means, if any of the rest of you have Rust questions and whatnot, I am still learning Rust, but if you want to pop into the Discord, I'm usually there. This weekend was a little off in that I was building shelving, stuff like that. But feel free to toss questions in there and just hang out. Cargo stream multiplexer. Oh, this is the wrong. Okay. Cargo stream. Oh yes, we are using the new changes directly. Okay, let's get this cleaned up, published. Yeah, there's some things in here I don't like, some things I do like. Let's start staging these. Status. What's this? Packet, we do not want that. Get rid of that. What's this one? Yes, we do want to rename ID there to stream ID. This is just a debugging thing. You can see that it's inside of Impl for debug. We do want that. We'll stage that. What about integration test? Just a space. Fine. Keep that. But this here. Alright, some of these we can start to stage already. Stage this block there, that one, that one. This one's good. This is the one we need to work through. Okay, we'll look at that now. One big function, and basically it's repeated. It's grossly repeated. Let's go look at this again. I am so glad we got movement working on that. I'm so glad. We'll put them away for a bit. Now we've got so much that we've done on this. All right, so what is this? This is where we run a channel. In Stream Multiplexer, we have collections of streams, and their data gets funneled into what I call channels. Now, here we have a channel ID, and the purpose of run channel is to set up a little task to process what the channel needs done. If we have 50 channels, we'll have 50 of these tasks spawned. Now, inside of here, we have a futures unordered, incoming packet sync, which is really where data comes in off the socket and we dump it into that sync. Then we also have the incoming packet reader RX. This is for moving basically streams between channels. So if we have a stream on channel 1 that needs to go to channel 2, it'll come in off of here. Then we take it, put it into the reader, take the data off of the reader, and toss it into the sync. So streams come in, get plugged into the futures unordered, packets come in through there and get tossed into the sync. Now, let's see. Incoming loop start. That is so helpful. So what do we do inside of our loop here? First, this all interesting. Yeah. Does Godot have a Rust plugin? And good morning. LVOLOL. I'm curious how you pronounce that. Godot does not have a Rust plugin, but it does have GD, like a GD native support. So I guess in a way it does. And if you're curious about getting that set up, I've played around with it, and it's really, really cool. So, here is the link. And you know what? Let's pop that up in the browser real quick. And here I've tested this to version 3.1.2 of Godot, but it looks like as of 10 days ago, they just bumped another version and it's updated to 3.2 stable, which is great. So now you could probably use this with the current download. But when you do look through here, definitely, read the docs, go through the examples. Um, but then when you get further down, they have these gorgeous Godot games in Rust, which are really nice. So you can actually, and this guy's got some interesting stuff as well. Oh, you haven't learned Rust yet? Oh, very cool. Well, welcome to the Rust learners. We're all kind of in this together. If you have Rust questions or you want to know kind of where to start, I have some suggestions. So, but yeah, by all means, hang out, see how it goes. I'm currently about 5 months into like working on Rust. Um, you know, was it 10 to 15 hours a week, trying to get good at it. And then, so what I'll do is I'll come in, do all this Rust stuff, and about 20 minutes I head off to my day job. So usually I start earlier. Today I started really late. I'm only getting about an hour and a half in. Does it feel more complex than other languages? Um, so I guess I'd say I'm proficient at like C, proficient at JavaScript. C++ I'm comfortable with. I wouldn't say I'm proficient. Proficient with Erlang. Um, I'm comfortable with Elixir. So compared to those languages, oh, and Java. Yeah, goodness, I'm proficient in Java. Um, I would say that it solves a lot of issues from other languages. Right? From C and C++, you're dealing with um, unallocated memories, nulls, things like that, right? A lot of those sort of pain points. Having to deal with memory between threads. Right? How do you deal with managing lifetimes of values? Right? And then you start bringing in Java, right? Things where you have multiple threads just kind of owning the same data, and you have to create mutexes to guard the data and that sort of stuff. So it feels a lot. I feel a lot more confident writing Rust than I do in those other languages, especially when I'm doing this sort of highly concurrent, multi-threaded stuff. It's like this gigantic safety net that just feels so very comfortable. So um, I really, really like it. And I would choose it over Java. I would choose it over C or C++. Um, like if I was starting something out here. I actually started this project using Erlang and Elixir, and I switched to Rust for the backend stuff. Yeah, whenever I get compiler errors, like strange, sort of weird compiler errors, actually Rust compiler errors are really, really, really good. They're so much better than other languages. However, still, they're strange to me because I don't understand them. And they do a very good job of trying to help you to understand them. There are tools available to, like if you still don't get it, you can hop in their Discord and toss the question out there and whatnot. Oh yeah, all those languages are great at concurrency. Java's great at concurrency, C++, C, right? But the types of errors that you get in those languages, those are amazingly tough to figure out. If you had two processes in Java overwriting data, or in any of those languages, I guess you couldn't really do it in Erlang the same way, unless you were using. There is a way to do it in Erlang, but you have to kind of cheat to do it in Erlang to overwrite data, different threads. Uh, well, they can do it, and they leave a lot to the coder to do it well. I mean, you have operating systems written in C++, and C. So, and Java. Yeah, there's a lot there for Java though. Their concurrency primitives in Java are really nice. Their concurrent hash maps and all of that. They have some fantastic data structures in Java. It's some of those data structures that I miss sometimes. I don't really miss the verbosity of Java. I feel like even Rust is a bit more terse than Java is, and kind of C++. Yeah, I agree with you there. They can all do it. I think Erlang does a better job of doing concurrency well. It takes that sort of a foot gun away from you. It's kind of a shared nothing environment, unless you cheat. All right. Erlang is great. Even the garbage collection in Erlang is great. This garbage collection in Erlang is done per process, and that's not an OS process. That's per kind of micro stack that they call processes. So I've never played around with. How do they say it? Is it Kotlin? Is Kotlin? I don't know how to say that, but I've never seen it actually. And Java, I had a great mentor. We built highly concurrent game servers, and there were some insanely hard bugs to figure out that I will never have in Rust. The second one, Kotlin with a soft O. Yeah. Okay. It looks like it's from another language. Trouble deciphering which language that would be from. Like which set of phonograms do you use? I'm actually having trouble finding that code. G status. Here, it's in multiplexer. Okay. What was that? Let's go back to multiplexer. Ah, there they are. Here we have our kind of tokens there. Oh yes, this had a lot of stuff just added to it, and I don't think I like all of it. Mostly because of the duplication. If I split this window, here. So same thing as before, for the futures and ordered. This is where the streams are stored as their data is being pulled off of them. Incoming packet sync, that's where the packets go once we're done with them. And this is how we get streams moving between these channels. Oh, like Elixir on top of Erlang. Interesting. That does sound nice. I mean, they did a fantastic job with Elixir. I like that their goal isn't to just have a language that just keeps being modified forever, but it's to have a language that is done. Kind of like Lua, I guess. Right? Lua, very few changes ever. That's cool. So we come in here. We're going to do a Tokyo select. In this case, let's add some comments here. There's a new stream to join this channel. Oh, wow. That is a massive move. Good for them. Good for them. I wonder if Oracle would leave them alone then. I wonder if it also solves some of those problems. Oh, that'd be interesting. It suddenly provided a way away from Oracle. So we have a new packet reader. We match the packet reader. Let's see, what's the alternate case? The alternate case is it doesn't exist. Okay, that didn't actually change. This code in here did. Wow, it's becoming their #1 suggestion. Huh. They must see a decent improvement either in app quality or number of bugs, perf, who knows? So what's actually going on here? Stream is moving channels. It should exist. How did this actually change? It's like, oh, we needed the packet reader stream ID, so we had to get that. Stream ID out of the packet reader. Wine packet, why? I didn't think I had this in the previous version. Or maybe it was just broken and wrong. Tokyo Select is, I guess it's kind of like, are you familiar with kind of KQs or like the kernel select, things like that? You basically have futures that could resolve. Okay, so there's this future here. We might get an incoming packet that comes in. Okay, and the other case is that we might have data come in from one of those streams already. So we might have a new stream, or we might have data that's coming in off of a new stream. And what it does is it looks at all of those futures and it says, okay, who's gonna be ready first? And it lets us handle that event. So that's basically what it does. It basically lets us register multiple futures and handle the one that is ready. And there's some sort of fairness algorithm in there as well. It's actually fairly complicated. But look at it. It's a macro. And it does a lot in here. Using bit masks. So it's just monitoring all those features that we might register with it, and we can handle them. It's not, however, you could have things that are not OS based. So you could actually create your own sort of structure that you can pass into a select. You can create your own future, and it doesn't have to be tied to a socket or anything else. It could be tied to maybe just I don't know, time changing. I guess that's still an OS signal, but you can create your own streams and have combinations of streams and whatnot. So it's much higher level, and you can basically await on whatever futures are there, futures or streams. That the stream running this channel. Now in this case, we're getting the data off of that and putting it in the new one, but which packet sync are we putting it in? Okay. So in this case, this is actually fairly complicated because of where data might be in the buffers when it is told to change channels. I'm going to leave that up to the consumers to figure out. In this case, pull any lingering data. Now, I'm not actually sure that this is needed, and we should probably test this. Why don't we, let's comment this out, make sure that it's actually needed. This was my first attempt at fixing that bug, because I thought it was here. And it might not be. Oh, that's a weird spot. Okay. There, better. Let's do that one and this one. Fletcher Goss is also streaming Rust Game Dev. Oh, cool. That's very cool. Actually, well, it's about time for me to stop. Maybe we should rate him. So in this case here, let's comment that out. I want to see if this stuff still works once we put in there. Because I would like to not have to do those elements there. If the future's unordered, we'll pull at the right time. Yeah. I think we can, we'll build this, test it out. Yes, this is the game server code. Didn't think you'd see two of those at once. Yes. Yeah, this is the game server. So we'll do this test, and then I gotta wind down here. I'm gonna get prepped to raid him. It compiled. Good. Rerun the client. Okay, move my windows around. There we go. Log in. Yeah. At 30 there. Okay, good. Wait, click on the puddle. Oh, we can. Okay. We don't seem to be losing packets. Good. I will not keep that that other change around. That will make Stream Multiplexer much happier. Oh, that'll be so much better. Okay, so I'll clean that up later. But I think not having those changes in there makes it much simpler. Oh, he's using Amethyst. Cool. Yeah, let's rate him. Yeah, we have a GUI. That's so here you can kind of see before we finish the raid. We've got a procedurally generated kind of island here. This isn't the greatest island. There are different kind of biomes and worlds. Let's choose a different one. Let's go Captain Fuzzy Pants. This guy is on an Arctic biome. Um, so the islands are all mostly round. They're kind of textured at the outskirts. They're generated by noise, different elements in there. But it's all dev art at the moment. Eventually this will be a little bit more, I guess, visually appealing. Oh, his peninsula is back. Oh no, that's just other puddle. Anyhow, but yeah, that's the game client so far, and going to different world or islands is possible, or had been possible. I think that's going to be coming up next soon. We'll do that. But I gotta get going. I'm gonna raid Fletcher here. So until next time, bye bye.